Okay, I guess since it is 11 minutes past, we can begin. So the other ones will get the recording. So today we are beginning with the one and only one situation. Remember yesterday and the other day we looked at the other two. We looked at the at least situation, the and situation, and the odd situation. So we are looking at the last one, the last situation today, which is the one and only one. So as those three words suggest, so in this event or in this situation, we look at a series of events which happen while others fail. So if for example, like in this example, we have three soldiers, A, B, and C, who aim to hit a target. But that target can be hit by one of them, because when one has hit that target, it becomes very, very, very hard for the rest to hit it because he has already done it. So we are saying this is a situation in which one of the series of events happens while others fail. So in this case, if soldier A hits the target, the other two are not going to hit it. If B hits the target, the other two will not hit. If C hits the target, then the other two will not hit the target. And then we are given that the probability of A hitting the target is a third, B hitting the target is a quarter, and C hitting the target is a fifth. So we are saying the three soldiers are aiming at together are aiming at hitting a monkey, each releasing a bullet. So we determine the probability that the monkey is hit by one and only one bullet. So that is our major interest. So these other two are, the last two are coming in as a by the way. But our major focus is a bullet, a monkey being hit by one and only one bullet, which can be by A or by B or by C. So we are going to look at how that is done. So in simple terms, we are saying for us to hit the monkey, it's going to be hit by either A, so the other two are going to fail, and that is why we have the prime. So the first one, A hits. So if A hits the target, then the other two are going to miss. Or we can have a target being hit by B and the other two miss. Or we can have a target being hit by C. I think here we had, there was some typing error. So this was supposed to be, so the first one, it is A who hit, the second one B hit. So this third one is supposed to be hit by C. So the A is prime. The B is also prime, and then C. So in the last one, it is C who is going to hit the target. Then I think it still persisted, but we are going to deal with it. So this word or, when we are using it between these two probabilities, it means addition. So this time it does not mean union. So we have A intersection B complement intersection C complement, meaning that it is only A who hit the target, plus A prime intersection B intersection C prime, implying that it is only B who hit the target. And then lastly, A prime intersection B prime intersection C. But we can go back a bit to find those primes. So probability of A is a third. probability of B is 1 out of 4. Probability of C is 1 out of 5. So A not hitting the target is going to be A prime, which is going to be 2 out of 3. Remember how we get it? We get probability of A, we add probability of A prime, and we equate that to 1. Then still for B prime, it's going to be, since this is 1 out of 4, the other one is going to be 3 out of 4. Then probability of C prime is also going to be 4 out of 5. Is that clear? Is it clear? How we get those A prime, the B prime, and C prime?
Yes, teacher.
Okay, so I guess we can proceed.
No, teacher.
Yes? Anyone who didn't get it well?
Teacher, me, I didn't.
Okay. So in the beginning, we said when we get probability of A, that means A is going to happen plus probability A prime, A not happening is equal to 1. So if we have A as 1 out of 3, then we add A prime, this gives us 1. So this means the probability of A prime is 1 minus a third. And when we substitute in a calculator, 1 minus a third gives us 2 out of 3. So that is how we get the A prime, the B prime, and the C prime. Is it now clear?
Teacher, I've understood. Yes.
Okay. So can I proceed?
Yes, please.
So we had substituted, the last one had a challenge. So here we are going to be multiplying. Let me hope these ones are okay. So the first one is a third times 3 out of 4 times 4 out of 5 plus 2 out of 3 times 1 out of 4 times 4 out of 5. Then A prime is 2 out of 3. B prime is 3 out of 4, and this is that. So here it is better for us to maybe have them in brackets so that we multiply. So 1 times 3 times 4.
12.
12. Then 3 times 4 times 5.
60.
Okay. So when we do that calculation, so it becomes 12 out of 60 plus 8 out of 60 plus 6 out of 60. So the LCM is the same. So we are just going to add 12 plus 8 plus 6, which gives us 20. Is it 26?
Yes, teacher.
So 26 out of 60. And that can be reduced to 13 out of 30 when we divide each item here by 2. So by 2 is 30, by 2 is 13. So we end up with the probability of 13 out of 30 as the probability of a monkey being hit by only one and only one bullet. Any questions, or we can proceed? Okay, I guess we can proceed. Then the second one, we have the probability that the monkey will be hit by 2 bullets. So there is a possibility that when each of them fire at that monkey, it is likely that 2 bullets are going to hit it. So we are saying that probability A is going to hit and B, then C misses. That is one option. Another option is A and C are going to hit while B misses. Then the last option will be A misses and then the monkey is hit by B and C. Is that clear?
Yes, teacher.
Good. So we go ahead to substitute. A was 1 out of 3, B was 1 out of 4, C was 4 out of 5. So after we have done our substitutions, I said it's better for us to have some brackets there. Then we do our multiplication. So the first one will be 4 out of 60. The second is 3 out of 60, and the third is 2 out of 60. And then we add 4 plus 3 plus 2, which gives us, I guess, 9. And if this gives us 9 out of 60, we divide by 3. So 3 is a common factor. And here when we divide by 3, it gives us 20. So that is why we have our final answer as 3 out of 20. So that is the probability that the monkey is going to be hit by 2 bullets. Then we also can have a scenario where the monkey is going to be hit by the 3 bullets. So A is going to hit, B is also going to hit, and C also hits. So that one is simple. We also just substitute there a third times a quarter times a fifth, and that will give us 1 out of 60. Any questions about the one and only one situation? Any questions?
No, teacher.
Okay, so we can proceed. Okay, then we have the probability that the monkey is hit. So this can be hit by 1 or 2 or the 3 bullets. So we are going to sum up where we had the probability that the monkey is hit by 1 and only 1 bullet. We add it to the probability that the monkey is hit by 2 bullets. And then we add the probability that the monkey is hit by the 3 bullets. So since we already had our answers, so we're going to add 26 out of 60 plus 9 out of 60 plus 1 out of 60. And what do we get when we add? Some of us can send our answers by the chat.
Teacher, the final answer is 3 out of 5.
2 out of 5.
3 out of 5.
3 out of 5. So we divide this by 6. So by 6 is 6, by 6 is 10, and then by 2 is 3, by 2 is 5. Thank you. So our final answer is going to be 3 out of 5. So we are saying alternatively, the probability that the monkey is hit, we are saying it can be hit by A or B or C, which will now mean union. Okay. When our odd is between the events, that is when it becomes a union. So which would be probability of A union B union C. And then using the other formula of probability of A union B, which is equal to probability of A plus probability of B minus probability of A intersection B. So when it now becomes 3 events, we have A plus B plus C, then A intersection B, A intersection C, and the B intersection C then plus the intersection last. So this is where we have, in case there are 3 events. And then we substitute in our values according to our probabilities. So the probability of A was a third, so that is why we have 1 out of 3. Probability of B was a quarter, probability of C was a fifth, and it cuts across. So where we just substitute and then use our calculators to get the answer. But we can first simplify some of them. But in the exam, in case such a number appears, you are supposed to just use your calculator and then substitute, because your calculator has the ability to input this function at once, and then it generates for us an answer. But for purposes of learning, we are saying 1 out of, like for example, this bracket gives us 1 out of 12. Second bracket gives us 1 out of 15. This one gives us 1 out of 20, and let's say this gives us 1 out of 60. So after that, then we add using a calculator. We do our operations using a calculator, and then we should be able to get the answer. So can we put our calculators to work?
Teacher, I've got 3 out of 5.
3 out of 5?
Yes, teacher.
Is the same for everyone? Those of us who are having calculators?
Yes, teacher.
Okay. So it is still the same, so it gives us 3 out of 5. In case there are any questions, please feel free to raise up your hand, or you send a message in the chat. So we are going to another subtopic, which is the law of total probability and the Baye's theorem. So we have so far seen that when we add the probabilities, they give us 1. So we are now going to add Baye's theorem. Remember, at the beginning of this week, we talked about, I think that was in lesson 3 or 4, we talked about conditional probability. That's because an event has already occurred, to some extent, it influences the occurrence of other events. So this is Bayes' theorem advances that concept and then builds on it to to come up with Baye'S theorem. So we are going to begin by looking at two events. So we have events A1 and A2, which are mutually exclusive and mutually exhaustive events. And that B is any event. So these A1 and A2 are happening because B has already occurred. And we are saying A1 and A2 are mutually exclusive, and they are also mutually exhaustive. So remember, with exhaustive, we said when we add their probabilities, they give us a 1. So we are going to look at this illustration. So we have a circle which is inside a given sample space. So that sample space, we shall have A1. So we shall have our events A1 and A2. But remember, because they are mutually exclusive, they do not occur at the same time. But then they are inside an event B. So meaning, if A is to happen, if A1 is to happen, B must have already happened. If A2 is to happen, B must have already happened. Now, if we are interested in getting the probability of B, so we are going to simply add. We are simply going to have A1, which is in B, so that is why we have A1 intersection B, because it is happening in B. Then also have A2 intersection B, because these events are already, the B has already occurred, and it is relating to occurrence of A1 and A2. So when we are interested in getting the probability of B, the probability of B is going to be A1 intersection B plus A2 intersection B. But remember, we are dealing with conditional probability to some extent, because A1 is happening because B has already happened. So meaning we are going to change the probability of A1 given probability of A1 intersection A2 into a conditional probability. So this is going to be probability of A1 happening because B has already happened. But then we realize that if we expand A1 given B, this is only going to give us probability of A1 intersection B divided by probability of B, which probability of B does not exist in the original equation, which is A1 intersection B. So what do we do to remove the B? We multiply the probability of B here, and we also multiply the probability of B here. Thinking, no? I've done it the wrong way. So we have A1 intersection B. So because B has already occurred, so we're going to change this to B intersection A1. And then we introduce the given. So B is happening because they are already happened. So when we expand B given A 1, this gives us probability of B intersection A1 divided by probability of A1, which A1 we do not have in this original. So we are going to multiply the A1 here, and we also multiply it here, so that we do not change the meaning. So we shall finally end up with probability of B intersection A prime being equal to probability of B given A prime times probability of A prime. I know this at the start is going to be a bit tricky and hard, but with practice, with more reading, we are going to be able to get it. So that was some little explanation, but I'm going to send you, I think in the group, a video which tries to explain more about the Baye'S theorem. So we have done for only A1, for A1 intersection B, but it is still the same process we are going to do for A2 intersection B. But because of time, allow me not to do that, and we just make a generalization. Allow me rub this. So I'm saying since A1 intersection B and A2 intersection B are mutually exclusive, then we shall have, like what I was explaining, probability of B. So this A1 intersection B changes the probability of B given A prime times the probability of A prime. Then A2 intersection B changes the probability of B given A2 times probability of A2. Taking us back to the other diagram we had, where we have events A1 and A2. They are happening and then leading to B happening. So that will be it. So that is the Baye'S theorem. And if we have events which are endless, A1, A2, up to AN, then this is how we summarize, how Baye summarized it, that we are going to sum up probabilities from I is equal to 1 up to I is equal to N, and then as we substitute in probability of B given AI times probability of AI. So if we had another event here, we would add, if we have maybe 3 events, we would add probability of B given A3, then we multiply this by probability of A3, but that one does not, we do not have it, so we can just ignore. So that is a simple summary of Baye's theorem. So we can now look at some examples. And we are saying this is the law of total probability, which also acts as Baye's theorem. Oh, I have someone who is lost. Okay, what I'm going to do, I'm going to share with you a video about Baye's theorem, and then you'll be able to grasp it in your own free time, because in this little time we have, if I have to explain everything, then we shall not do much. So I will send the video. So let us do some examples. Okay, that one you can leave. So who can read for us this example?
Me, teacher.
Okay, go ahead.
The probability that it will be sunny tomorrow is a third. If it is sunny, the probability that John goes to the farm is 4 out of 5. If it is not sunny, the probability that he goes
To the farm, I think that was a spelling error.
the farm is 2 out of 5.
So we find the probability that John goes to the farm tomorrow. So here we have two methods that we can apply. The first one is when we use a tree diagram, and then the second one is when we use Baye'S theorem. So allow me to ask Patience to say hello to us. I don't know whether she's new. And Jemima, or they have just changed the names.
Teacher, for me, I'm not new.
Okay, good. Okay, I think as we wait for Patience, let's try to continue. So let's begin with the tree diagram. I guess it's going to be a bit easier. So we have two situations that are going to happen. We begin with the two branches. The probability that it will be sunny tomorrow is a third. If it is not sunny, what will happen? So we have that simple diagram. So the probability of being sunny and then not being sunny. So if this is a third, this is going to be 2 out of 3. Are we there? Then, if it is sunny, the probability that John goes to the farm is 4 out of 5. So maybe we say John going to the farm. This is 4 out of 5. Then John not going to the farm on a sunny day is going to be 1 out of 5. Then we got this other statement. If it is not sunny, the probability that he goes to the farm is 2 out of 5. So this is 2 out of 5. And then we also have him not going because it is not sunny, which will be 3 out of 5. Any questions before I proceed about this Venn diagram?
No,
Any
teacher.
questions, please?
No, teacher.
Okay. Then from this Venn diagram, what is the probability that John will go to the farm? From our tree diagram, where is John going to the farm? So we have two situations here. It is the sunny, okay? It is sunny. John goes to the farm. It is not sunny, but then still John goes to the farm. Those are the two situations that we have. Are we there? So this is going to give us, we are going to say probability of John going to the farm is probability of S intersection G plus probability of S prime intersection G. So which gives us a third times 4 out of 5. Then we add, it is not sunny, 2 out of 3 times John goes, which is 2 out of 5. So this would be 4 out of 15. And this will also be 4 out of 15. And when we add these two, 4 plus 4 gives us 8 out of 15. Any question with the Venn diagram? How to use the Venn diagram to answer such a question? Okay. It means that it is okay. I would suggest that we take a minute to note it down because it is not part of the slides that I had sent. So we can take some 2 minutes to write it down. Now the intersection for this case means that we multiply because these events are independent. Then the addition, yes, the or, it will be or when we are beginning it, only that I didn't put that step there, is the one which enables us to add. I hope Jemima, you answered. Then I have another message, I think. No, that was it. So when you finish writing, you just let me know. Okay, I've seen Sobla has finished. Anyone else? Such that we could do using the formula of Baye'S theorem. Okay, let me. Okay, Kenzie has also finished. So I think we can wrap and then we do the other way. So we are summarizing the information first. Probability of S is Sane is a third. If it is not Sane, it will be 2 out of 3. And that the logic is simple. Just equate this to 1 and then say a third plus probability of S prime is equal to 1. So the S prime gives us 1 minus a third. Gives us 1 minus a third, which is 2 out of 3. So like the way we have it here. Then we have this statement, if it is sunny, so meaning the sun, the sunshine comes first. Okay, so that is the initial condition. The probability that John goes to the farm is 4 out of 5. So that is why we have probability of G given S. Probability that he goes to the farm given that it is sunny, which is 4 out of 5. Then also have, if it is not sunny, the probability that he goes to the farm is 2 out of 5. This was supposed to be 2, so it is 2 out of 5. Now, then we find the probability that John goes to the farm. So the probability that John goes to the farm is going to be probability of G of him going, given that it is sunny, times probability that it is sunny, plus probability of him going, given that it is not sunny, times probability of the day not being sunny. Then we do our substitution. Then we substitute. So this is 4 out of 5. We multiply by probability of it sunny, which is a third. Then we add 2 out of 5 times the probability that the day is not sunny, which is 2 out of 3. So still this gives us 4 out of 15 plus 4 out of 15. And when we add this, we get 8 out of 15 which is the same answer like the one we got while we were using the tree diagram. Jemima says she can't see my screen. Is it still not visible? Is it still not visible?
So we can see.
Maybe Jamima, you first leave the meeting and join in again. Or let me just stop share and then again share. So is this okay as well? Okay, we can go to the next example.
Teacher, I'm not seeing the screen. I can't hear you.
The screen. I'm sharing again. Are you able to see the screen now?
Yes.
Okay, someone to read for us that example. Who is reading for us? Can we?
A good footballer.
Okay.
A good football striker is nursing his injury in his leg. The probability that his team will win the next probability that his team will win the next when he plays is 4 out of 5.
When he plays, I think there was a word
Otherwise,
there.
it is
Okay, so we have this example.
Teacher, should I continue?
Yes, please. Okay, the probability that the team will win the next match when he plays is 4 out of 5. Otherwise, it is 2 out of 3. The probability that he will have recovered by the time of the match is 1 out of 4. So we find the probability that his team will win the match. So we can begin with one of the methods. So let's begin with the tree diagram. So the player is nursing his leg. So the probability of him recovering and not recovering by the time of the match So the probability that he will have recovered by the time of the match is 1 out of 4. So the other one would now be 3 out of 4. If he has recovered, the probability that his team will win is 4 out of 5 if he plays. So the probability that his team will win the next is 4 out of 5, otherwise it is 2 out of 3. So this would be 4 out of 5, and its opposite will be 1 out of 5. Otherwise, if he doesn't play, it will be 2 out of 3, the chances of the team winning, and the team not winning will be 1 out of 3. Now we ask ourselves, what is the probability that the team will win? Where do you think that will happen? On our tree diagram. No idea? Okay, his team will win if we do this movement. He has recovered and he plays and the team wins, or he has not recovered and he doesn't play but the team still wins. So that will be our simple. So probability of the team winning is probability of R intersection W, or probability of R prime intersection still W. Then here we add then we substitute. This is 1 out of 4 times 4 out of 5. Then we add 3 out of 4 times 2 out of 3. So this gives us 4 out of 20 plus 6 out of 12. What do we get when we use our calculator?
7 out of 10.
7?
7 out of 10.
7 out of 10. Okay. Then we look at the alternative method. I'm going to share that, don't worry, I've got a way of extracting it. So we have probability of him recovering, which is 1 out of 4. And the probability that he will not have recovered by the time of the match, which is 3 out of 4. Then probability that the team wins, given that he has recovered, which is 4 out of 5. And the probability that the team wins, given that he has not recovered, which is 2 out of 3. Then we say our probability of the team winning is probability of W given A times probability of R. Okay, sorry, W given R times probability of R plus probability of the team winning, given that he has not recovered, times probability of him not being able to be recovered. So we get 4 out of 5 times a quarter plus 2 out of 3 times 3 out of 4. And when we substitute, we still get 5 out of 20 plus 6 out of 12, which still gives us 7 out of 10. So it would still be the same. So we are stopping here for today. I'm going to send you some numbers to do. So make sure you do them over the weekend and you submit them for marking.